Right, so now 2012 B1. Manufacturer, so he's making canned tomatoes, and he wants to minimize the amount of metal used to make his cans. So he has to make a cylinder, etc., etc. It's exactly the same as the example I did earlier today. You have a can, height h, radius or volume is to be 200 milliliters, 200 cc's of tomato. Calculate the area. In fact, it's not really a calculation, but if you need a bit of help here, you need to picture the can as unrolled like this. So the area for the circles is pi r squared and pi r squared. So there's 2 there, 2 pi r squared. And this here, what's the height here? H, isn't it? And the circumference, how big is this? Well, that's how big this is here, isn't it? And if you remember middle school, what is the circumference of a circle? 2 pi r. So it would be plus 2 pi r h. That's the first part done. What's wrong?
Show that area can be used as blah blah blah.
Yeah, I would just write in here 2 pi r and then just here put in an or, and if I saw that diagram, that would get you full marks.
How would you picture it like this?
Because we want surface area, so we have to unpack it and picture it as flat. What you need to picture is we have a piece of metal and we cut out the shape and then we roll it up. If you need to find more examples on the internet of this, I think this is called a net. A net is when you take a shape and unfold it. I believe so. Okay. Part B is to calculate the volume. So, sorry. Yeah, volume. It's 200. Yeah, if you have a question, go ahead. Oh, the question is visualizing, is it? Yeah. The can has the 2 lids, so the lid pops down, and then it rolls out. So you have the rectangle with a circle and a circle. That's what's happening. It's hard to picture. I'm sure there's a video or something of this. Is it okay? Can you picture it? It rolls out. 2 lids pop down. Okay, so volume. What's the formula for volume? Yeah, what's wrong, Arif?
That's the answer for A.
Yes.
That's already given.
I know it says show.
So the diagram is the answer.
The diagram is the showing.
Just don't be.
Is this direction? Is it okay?
Is it
That's normal enough, actually, for this type of question. What's wrong?
so easy?
Yeah, well, take what you can get. All right. B. Volume is 200, which is pi r squared h. So what's h equal to? 200 over pi r squared. We put that back into the formula for area, and so now we have area in terms of r. 2 pi r squared plus 2 pi r h. Some stuff cancels, goes with that, that goes with that, and I end up with my answer. Area is 2 pi r squared plus 400 over r power minus 1. Part C is find the minimum value, the value of r that makes this a minimum. So that's straightforward. To make a minimum, we need to make its derivative, which is 4 pi r minus 400 r minus 2 equal to 0. That's how we make a minimum or a maximum. So to find a minimum or a maximum, we need to make the derivative 0. You all know that, we've seen that. So we have now 4 pi r minus 400 over r squared needs to equal 0. 4 pi r needs to equal 400 over r squared. So r cubed must equal 400 over 4 pi. So now we have the answer really, 400 over 4 pi, and then cube root that. And I got r is 3.169. Double check that this actually is a minimum. So a quick check here that this is a minimum. The second derivative will be 4 pi plus 800 or minus 3. Is that positive or negative for this value of r? What do you think? Positive or negative for this value of r? What is it? Come on. Positive. So if it's positive, what type of solution is that? Minimum. Yeah, minimum. Yeah, that's what you did, not what you said. Alright, and then the last part here is to work out the height, but you have a formula for height. It is 200 over pi r squared. 200 over pi r squared. So 200 over that answered squared. Right. 6.338. Or if I do this to 3 significant figures, it'd be 3.17 centimeters, and then this would be 6.34 centimeters. And that is question 1 done from section B.